Hi friends, welcome to Devrat Knowledge Villa. You are watching our English video series of operating system and learning memory management. Today's our topic is space to address translation. Before today, we have already discussed address to space translation as well as we have discussed translation fundamentals. So guys, if you are still remain to watch our earlier videos, so you can click here in I button and you can watch our earlier videos. In earlier translation fundamentals, we have discussed if we have n bit, so we can generate 2 raised to n number of addresses. As well as we have discussed if we have a 1k in terms of data, so we can write 1k is equal to 1024, it means 2 raised to 10. Or if 1 mega, so it is 2 raised to 20 and 1 giga is 2 raised to 30. So on 2 raised to 40 and 2 raised to 54 tera and peta. Let's start. Today's video session is about space to address translation. Like we have already discussed one equation, that was memory size is equal to total number of address location into size of address location. This equation we have already learned in our earlier video. Now we want to find out total number of address. So thing is that we want to do reverse procedure, so we will make total number of address translation and we will use to find out this equation. Like if you want to find out total number of address, so we can divide it with the memory size divided by size of address location. So if you want to find total number of address location in this equation, so here what we will do, we will keep memory size and we will divide memory size with the size of address location. Get it? So thing is that let discuss with the one example. Suppose we have a one block of memory and size of this block is 1 KB, and in terms of this block we want to store number of addresses with the 1 byte. So we have to think that if we have a memory block of 1 kilobyte, and this in this memory block we want to store total number of addresses which size is 1 byte. So how many address we can store here with the size of 1 byte into the 1 kilobyte memory. So let's see, our memory size is 1 kilobyte and size of address is 1 byte. So it is 1 KB divided by 1 byte. Yes, size of memory is 1 kilobyte and size of address or location is 1 byte. So let's see, it will if we will solve this equation, so 1 byte into 1 byte, so it will remain 1k only. Get it? So 1k means 2 raised to 10. 1 kilo it is 1024 and 1024 is nothing but 2 raised to 10. Same thing, if someone asked like if we want to generate 2 raised to 10 addresses, so how many bits require? 10 bits. Get it? So earlier question was how many total number of address we can generate. So total number of address or location we can generate 2 raised to 10, or we can say that 1024 addresses. If someone asks us in detail to generate this number of addresses, how many bits are required, so we can say that 10 bits required to generate this addresses. Get it? Actually formula is look like we have already learned, if we have a n bit, so we can generate 2 raised to n addresses. Now I want to find out this n. If we are able to generate 2 raised to n addresses, so how many bits we require? Bit means n. Get it? Suppose it is 2 raised to 10, so how can I find out the n? So directly if we have a n bit and we are able to generate 2 raised to n addresses, and suppose we want to find out the value of this n, so we can find out n is look like log 2 base n. So we will not go into this equation logarithmic base, we will solve look like that simply. So you can learn easily and you will be able to solve out this thing in your end semester exams, as well as if you are appearing into the any competitive exams like GATE, NET, SLAT, whatever. See here, one more example, a memory block with the 32 KB and address of size of each address is 1 byte. So let's see how many address we can store with the 1 byte into the block of 32 KB. So we want to find out number of addresses. So how we will able to find out? We have a total memory size that is 32 KB. We will divide 32 KB with the size of each address. Get it? So 32 KB divided by 1 byte. So 32 divided by 1, it will be 32, and byte it means there is remain only kilo, so it will be 32 kilo. Get it? Kilo means 2 raised to 10 and 32 means 2 raised to 5, so it will be 32 means 2 raised to 5 and kilo means 2 raised to 10, so it will be 2 raised to 5 into 2 raised to 10. So we can write like 2 raised to 15 in place of 2 raised to 5 into 2 raised to 10. Yes, definitely it will be 2 raised to 15. Get it? So these are the number of address. How many number of address we are able to generate? We are able to generate 2 raised to 15 addresses. It is our answer. But again, someone asked to us in detail how many bits required to generate 2 raised to 5 addresses. So we can say that total 15 bits required to generate 2 raised to 15 addresses. And our question was, into the block of 32 KB memory with the size of each address 1 byte, how many address we are able to put? So we can put 2 raised to 15 addresses maximum into the 32 KB memory block with the size of each address is 1 byte. Let's see with one more example. Size of memory block is 16 MB and size of each address is 2 byte. Here size of address is going to be changed. In earlier example, size of each address was 1 byte. Here size of address is 2 byte. So we want to find out number of addresses. Yes. What is the equation? We will divide entire memory space divided by the size of each address. So total space is 16 MB. 16 MB divided by size of each address is 2 byte. So 16 MB divided by 2 byte. So 16 divided by 2, it will be 8, and byte will thrown out. So we will require 8. We will get 8 M. Get it? 8 mega. So mega is nothing but 2 raised to 20, and 8 is equal to 2 raised to 3. So we can write look like 2 raised to 3 into 2 raised to 20. If we will combine both, so we will get 2 raised to 23. So our answer is how many number of address we can place in this memory block with the size of each address is 2 byte. So we can say that we can place 2 raised to 23 addresses here into this memory block. And if the question is how many bits required to generate this 2 raised to 23 addresses, so we can say that 23 bits required. Get it? Last example, that is 16 GB. If we have a total space is 16 GB, so and we want to store number of addresses, each address with the 1 byte. Here again we are going to decrease the size of address. Get it? So how many number of address we can generate? Number of address we can generate, total space is 16 GB. 16 GB divided by 1 byte. So we will get 16 G. Get it? Giga means it is 2 raised to 30, and 16 means 2 raised to 4. So we will get 2 raised to 4 into 2 raised to 30. And finally we can write look like total 2 raised to 34. Yes, definitely. So we can generate 2 raised to 34 addresses, or we can say that we can place 2 raised to 34 addresses here into the size of 16 GB block with the size of each address is 1 byte. Get it? And we can say that to generate 2 raised to 34 addresses, we will require 34 bits to generate this number of addresses. So that is the all about space to address translation in terms of memory management. Hope you are understanding very well. Our next session will be about the to compute the number of frames and number of page. So thanks for watching Devrat Knowledge Villa. If you are still remain to subscribe our channel, so please subscribe our channel and get every times new videos regarding to the operating system.